All right, hello Algebra 2. Now we are going to make our way into solving 3x3 systems and kind of transition from doing the 2x2s. So when we did 2x2s, you noticed there were three different types of solutions we could possibly get. You could get one solution, which meant that when you graphed your lines, they would have a different slope and would cross at exactly one place. Or you could find that it turns out both equations were exactly the same line, so they basically lie on top of each other. That means you have infinitely many solutions. Or you would have noticed that they have the same slope, but a different y-intercept. So that's when you get things like 5 equals 0. Obviously, that can never be true. Infinitely, that's when you get things like 0 equals 0 or 5 equals 5. It's always going to be true. One solution will be something like x equals boom, and then you can substitute and solve for y. All right, so that's the kind of situation you would look for. Well, we're going to then move this a little bit bigger and solve a 3x3. So 3x3 is describing how planes can intersect. So again, you can have just one intersection. Think about the corner of a room where all three walls connect. And so that would represent one solution, which would be an XYZ. You could have infinitely, if you think of the spine of a textbook where all the pages go through that spine, that means you have your infinite solutions. What we are going to do with that, though, is we will usually have an x, and we will look at how y and z relate to x. So we won't just say infinitely many solutions, but that's coming. And then you also have the possibility of no solution. The three planes don't all intersect at one point or all the same points. So this is, there are no common points for all three planes. All right, so that's the easy part, just kind of recognizing the possibilities. The harder part is going to come solving. These really require being organized. You cannot solve a 3x3 if you're not really paying attention to what you're doing. So let's do sort of a simple one first. I always like to label my three equations A, B, C. And I like to keep track of what I am doing to each equation so that I can go back if I make a small mistake. Now, the very first thing you should look down your x's, down the y's, down the z's. You're looking for the same coefficient but opposite signs and how you could eliminate, because we want to eliminate one of the variables as quickly as possible. Now in this first example, it really doesn't matter. They all look like they are good candidates. So I'm going to just make the decision that we are going to eliminate the y. Okay, so that means I'm going to start off and I am going to add a and b together. So if I add a and b together, since one has a plus y, one has a minus y, they're going to go away right away. So what I end up with is 2x, the y's will go to 0. In this case, the z's went to 0 as well, which makes this an easier problem to start off with. And then 3 plus 1 is 4. So right off the bat, I get that x is going to equal 2. All right, awesome. So I have my first solution. Now we want to bring everyone into play, so I am going to now add b and, let me see, I still want to eliminate y, but I know x, so let's add a plus c. So let me take this back, and we're going to add a plus c. All right, so we have a plus c. And the reason why I'm doing that is, again, I want to eliminate the y. So when I do that, x plus a negative x, that goes away. Y plus a negative y, that goes away. But I do end up with 2 times z equals 1 times a negative 1, which is 0. Dividing by 2 would still leave me with z equals 0. So I have 2 of my solutions. So all I have to do now is back substitute to solve for y. So I'm going to plug it into my equation A. I know that x is 2 plus y plus z is 0 equals 1. So I can subtract 2 from both sides, and you get that y is going to equal a negative 1. And then again, we always write our solution as an ordered pair, so x, y, z is going to equal 2, negative 1, 0. Okay, so that's your first 3 by 3. That one, granted, was kind of easy, so we want to get a little bit more involved on this next one. All right, so what I'm going to do is I'm going to change that color, and I'm going to change this color. So we want to try and keep our things color-coded. So just like before, I'm going to label A, B, and C so we can keep track of what we're doing. And again, I'm going to look down my list, and I notice that the x's have 1, 2, and 3. My y's have 2, 2, and 4. Since 4 is a multiple of 2, and one of them is negative, that might be a good candidate because the z's have 1, 3, and 5. So once again, okay, so we are going to be eliminating the y, and so I'm going to show how we're going to proceed. So we're going to start with A, and I'm not going to do anything to A, but I am going to multiply everything in B by a negative 1. So that way the 2y will cancel with the other 2y. So A I just rewrite as is because we're not doing anything to it. So this equals a negative 12. B is going to become negative 2x minus 2y plus 3z equals a positive 2. So then when I add those together, I have a negative x, my y's canceled, I have a negative 2z equals a negative 10, and if you don't like all those negatives, it's totally okay. You can multiply everything by negative 1 as well, as long as you do it to everything. So now I have an equation that just has x and y in it. I need another equation, because that's your goal with 2 by 2s, is you want to immediately create a 2 by 2. So I need to create an equation that has x and z, but also uses equation c, because I haven't used equation c yet. So let's also put up here. So what I did was a plus the opposite of b. That is what we did there. So next thing, since I have a negative 4y, what I'm going to do is 2 times b, and I'm going to add that to c. That's going to be our strategy. So if I'm multiplying everything in b by 2, that's going to give me 4x plus 4y minus 6z equals negative 4. Make sure you multiply all the way through. That's one of the mistakes that is pretty common. And then c I can just rewrite as it is. So this is 3x minus 4y minus z equals 11. So we go ahead and we add those two together. So I have 7x, again my y's cancel, minus 7z equals 11 minus 4 is going to be 7. And if you like, it might be easier, we can simplify this since everyone has a 7 in front of it as x minus z equals 1. So notice now I have 2 equations in just 2 unknowns, and so I can solve for a variable, because once you get that first variable, everything else is just back substitution. So based on what we did yesterday, I am going to rewrite this last equation, but I'm going to multiply everything by a negative 1, so that I have a negative x plus z equals a negative 1. If I add those two together, my x's go away. I have 3z equals 9 And voila, we have our first variable. Once you have that first variable, the rest is going to come right out because it's just back substitution. So you work backwards very kind of step by step. I'm actually going to go to this equation for my back substitution because I only want one other variable to have to work with. So I'm going to solve for x. X minus, I now know that z is 3 equals 1. So x equals 4. I have two of my variables. And to get the third, I go back to my original equations. I can choose any of them. It doesn't matter. I'm going to go to equation A. I know that x is 4 plus 2 times y minus 5 times 3, so minus 5 times 15 equals a negative 12. So I have 2y minus 11 equals a negative 12. So 2y, add 11 to both sides, is going to be a negative 1. Y is going to equal a negative 1/2. And that is going to give you your final answer, which we want to write as an ordered pair once again. So x, y, z equals 4, negative 1/2, 3. So now you've seen one or two. Sometimes they're a little bit easier, sometimes they're a little bit harder. For the most part, I'm going to try and give you whole numbers as your solution so you know you're in the right path. But these really take practice. And I also want to emphasize there is no one way to do these. Everyone might have a different method, but the basic idea of trying to create a 3x3 into a 2x2 so that you can solve for one variable and then everything becomes back substitution, that's your typical strategy. So let's look at this system here. Notice that I have xyz, xyz, and then I have no z. So that's kind of like a gift. Since I have no z in this last equation, that means I want to eliminate z in this equation. Then I'll have a nice 2x2. So in order to eliminate z, it looks like it's already set up. If I add the two equations, my z is going to go away. So I'm going to add a and b, and I get 6x plus 2y equals 8. Well, so now I have two equations in two unknowns because I already have my c and I have this equation here. So what I'm going to do is I'm going to multiply everything here by 2 and write it down below. Actually, I'm going to multiply everything by negative 2. So if we multiply by a negative 2, I have a negative 12x. I have a minus 4y equals a negative 8. So I get 0 plus 0 equals 2. Well, 0 doesn't ever equal 2, so here's a case where you have no solution. And you're done. There's nothing else you have to do. Okay? But also notice that when you had that, you were missing one of the variables. It was kind of like a gift. That means use the other two to eliminate the same variable. So that strategy still works, even if you had a solution. All right. Next one, so let's look at our three equations, A, B, and C. Which one looks like it would be the easiest to eliminate? I'm going to choose Z because I see positives and negatives with all the same coefficients. All right, so I'm going to start off with A plus B. So if I add these two together, again, I'm trying to eliminate Z. I'm going to have x minus 2x, 2y minus y. Z's go away. 3 minus 1 is 2. So negative x plus y equals 2. All right, the next thing I'm going to do is I want to eliminate my z and create a 2 by 2 having used all three equations. So I'm going to add b plus c. So b plus c gives me 6 minus 2 is 4x and minus 4y. My z's go away and then I have a negative 8. Okay, well, let's see. We have two equations in two unknowns, so now it's back into familiar territory. I think what I'm going to do is multiply this top one by 4. So that gives me a negative 4x plus 4y equals 8. And notice what happens is I get 0 equals 0. So yes, I have infinite solutions. However, you're not allowed to just say that, because even though I can plug in anything for one of the variables, the other variables, like if I plug in anything for x, y and z are going to be controlled by what you plug in. So this is what we are going to do. We are going to let x equal x. I know that sounds mundane, but that's what we're going to do. Okay, so x equals x. So let's look at this equation we have right up here, where we added a and b. What I'm going to do is, I know now that y, I'm going to isolate y. So y equals, I'm going to add x to the other side, x plus 2. So I have x equals x. I have y equals x plus 2. So what I'm doing is I'm rewriting each variable in terms of x. So x can be anything, infinite solutions, but y and z are controlled by whatever you initially plugged in for x. So now we have to find that third relationship. So I'm going to take my equation A, and I know that x is x. I know that y is x plus 2. Z is what we want to isolate, and that all equals 3. So that's plugging that into equation A. So let's simplify this. X plus 2x plus 4 minus z equals 3. So we want to isolate z. So I'm going to add z to the other side and subtract 3 from this side. So this gives me 3x plus 4 minus 3 equals z. So 3x plus 1 equals z. So this will be 3x plus 1, and that's how we write our ordered pair. X plus 2, 3x plus 1. It still represents an infinite solution, but it's showing the relationship that each variable has to the x. And you didn't have to choose x as the let x equals x. Any of them would have been fine. Okay. In the process of solving 3x3s, we've done it very generically. Now let's put it into a situation where you actually have to come up with the equations and then solve. So first thing we want to do is identify our variables. So we have this, you found $6.60 on the ground at school. They're all in nickels, dimes, and quarters. You have as many quarters as dimes, and you have 42 coins in all. How many of each coin do you have? All right, so we are going to come up with an equation for this, but let's first identify our variables. I'm going to let x equal nickels, which, remember, a nickel is worth 5 cents, so every x I put in is worth 0.05x. I'm going to let y be my dimes. Remember that dimes are worth 10 cents, so 0.1 times y represents the value of each y. And z is going to be my quarters, which are worth 25 cents. So when I'm talking about the value of something, each z is worth 0.25. So in general, when you're dealing with numbers of tickets and costs of things, these type of equations are going to have three, so our A, B, and our C, one of them is going to deal with the full quantity that you have, the number of tickets, the number of coins. One is going to deal with the value of those coins, and one of them is going to be a relationship between those coins. So let's do the quantity one first. The quantity is the easiest one to set up. They told us that we have 42 coins in all. So that's a quantity. So that means that x plus y plus z, the number of nickels, dimes, and quarters, the quantity that I have is 42. The value of all those coins is $6.60. So now we're going to put in the value with our x, y, and z. So that means that 0.05x plus 0.1y plus 0.25z equals $6.60. And if you don't like the decimals that come up in this, notice there are 2 decimal places at most. I can multiply everything by 10 here, actually 10 by 100, to move the decimal place 2 places, so that I have becomes 5x plus 10y plus 25z equals 660. So we wanted to move the decimal place 2 places. All right, our last one is the relationship. Okay, so the relationship says that you have twice as many quarters as you have dimes. Twice as many quarters as you have dimes. So what happens here is people sometimes will then say, oh, okay, so quarters, z equals 2 times y. But you want to think about this. Sometimes it helps to actually, so here's quarters, here's dimes. I know I have twice as many of the quarters, but we want to make an equation that makes them equal. So in order for them to be equal, since I have more quarters, I need to have twice as many dimes to equal the number of quarters that I have. So writing this as an equation, my z is going to equal 2 times y. So in other words, if y was 5, that means I had 10 quarters because I have twice as many. So that's the one you always have to kind of make sure you set it up right, because the most common mistake here is people say 2z equals y, but you want to make them equal to each other. So I need to double the dimes so that they equal the quarters. All right? Okay, we have our 3 equations. We're ready to start solving. So notice that in this case I can use substitution because I already have a relationship here, which means I don't have any x value. So I'm going to substitute c into both a and b, and that'll only give me then 2 equations and 2 unknowns. So a is going to become x plus y plus 2y equals 42. So in other words, this becomes x plus 3y equals 42. And equation b is going to become 5x plus 10y plus 25 times 2y, because that's what z represents, equals 660. And if we simplify this out, that gives me 5x plus 50 plus 10 is 60y equals 660. So notice now I have 2 equations in 2 unknowns, and we want to think about, all right, how do I want to solve these? So let's see, we could eliminate x. So what I'm going to do, notice in this equation, everything is divisible by 5. They're all nice, and I like to make things smaller than make things bigger, but that's, again, you have a calculator, you can choose what you want to do. So I'm going to rewrite these. So this one will come over here, x plus 3y equals 42. This one I'm going to divide everything by a -5, so that I have a negative x minus 12y equals 660 divided by 5. You can work that out on a calculator, is going to be a -132. And so now I can add these together, and I'm going to get a -9y equals a -90, so that y is going to equal 10. As soon as you get that first variable, it's like, woohoo, now all I have to do is back substitute. All right, so I know that if y is 10, I'm going to come back up to where z equals 2 times my y. So I know that z is going to be 20. And now let's find something that just has x and y as well. So we know that x plus 3 times y, 30 equals 42, so x is going to equal 12. So that means I have 12 nickels, I have 10 dimes, and I have 20 quarters. And you have a built-in check. You could calculate what does that equal in terms of total value, and it should come out to be the $6.60. Okay, hope that helped.